Okay, so today I'm going to be showing you how to do problem number 70 from the Chapter 6 homework set. The problem is a 60 kilogram soccer player jumps vertically upwards and heads the 0.45 kilogram ball as it is descending vertically with a speed of 25 meters per second. If the player was moving upward with a speed of 4.0 meters per second just before impact, what will be the speed of the ball immediately after the collision if the ball rebounds vertically upwards and the collision is elastic? If the ball is in contact with the player's head for 20 milliseconds, what is the average acceleration of the ball? Note that the force of gravity may be ignored during the brief collision time. So the first thing you want to do is start off by drawing a diagram. You want to draw two diagrams for this problem, a before diagram and an after diagram. I'm going to start with the before diagram. I made the positive direction the upwards direction, and I made the mass of the person mass 1 at 60 kilograms and the mass of the ball mass 2 at 0.45 kilograms. Then I labeled the velocities, and we know the person is heading upwards at 4.0 meters per second and that the ball is heading downwards at negative 25 meters per second, and this is negative because we made the positive direction upwards. Then you're going to draw an after diagram. And the after diagram, the masses obviously stay the same, and you know the person will be accelerating towards Earth at negative 9.8 meters per second squared. And you also want to find what the velocity of the ball was after the collision. So since it's an elastic collision, we can then label, we then know that this is the equation. The mass 1 times velocity 1 initial plus mass 2 velocity 2 initial is equal to mass 1 velocity 1 final plus mass 2 velocity 2 final. So then you can plug in the different values for the variables in the equation. So we know the mass 1, since we labeled the person as mass 1, is 60 kilograms and it has an initial velocity of 4.0 meters per second. And then we know that the ball's mass is 0.45 kilograms and has an initial velocity of negative 25 meters per second. And then the masses will stay the same in the after part, so it will be 60 kilograms V1 final plus 0.45 kilograms velocity 2 final. Then we're going to simplify, and we get 240 kilograms meters per second plus negative 11.25 kilogram meter per second is equal to 60 kilogram velocity 1 final plus 0.45 kilograms velocity 2 final. And then we are going to isolate the velocity 2 final, since that is what we want to find. And you only have to go as far as isolating the 0.45 kilograms V2F because it will be useful later on. So we get 228.75 kilogram meters per second minus 60 kilogram V1 final is equal to 0.45 kilograms velocity 2 final. Then we also know that the kinetic energy through this system is going to be conserved since it's an elastic collision. We know that the formula for the kinetic energy conservation is V1 initial minus V2 initial is equal to the negative quantity of V1 final minus V2 final. Then we can plug in the values, and we know the initial velocity for the V1 is 4.0 meters per second, and we know that the velocity of 2 is negative 25 meters per second. And then we can distribute the negative sign here to get negative V1F minus plus V2F. Then we can simplify, and we get 29 meters per second equals negative V1F plus V2F. Then we want to isolate the V1 final to plug into this equation so that we will be able to find velocity 2 final, which is the velocity of the ball after the collision. So then we get negative 29 meters per second plus V2F is equal to V1F, because you had to multiply this whole thing by negative 1 in order to correctly isolate V1F. And then you can plug it back into the equation, and you will have 228.75 kilogram meters per second minus 60 kilograms times the quantity of negative 29 meters per second plus V2F is equal to 0.45 kilograms V2F. Then you can distribute the 60 kilograms to this, and you get 228.75 kilogram meters per second plus 1,740 kilogram meters per second minus 60 kilogram V2F is equal to 0.45 kilogram V2F. Then you can move the 60 kilogram V2F over here and add these together to get 1,968.75 kilogram meters per second is equal to 60.45 kilogram V2F. Then you want to find what V2F is, so you will divide both sides of the equation by 60.45, and you will get velocity to final is approximately 33.33 meters per second. And when you multiply it out, it gives you 32.5, but you can round that to make 33. So that is the first part of your answer, which is what is the velocity of the ball after the collision. Then you want to find what the acceleration of the ball is after the collision. So we can use kinematics, and we know that the velocity final is equal to the velocity initial plus the acceleration times time. And in the problem, it stated that the collision was 20 milliseconds. So we can change 20 milliseconds into seconds by moving the decimal place over 3 times. And we can plug that in for 33 meters per second was our final velocity is equal to negative 25 meters per second, our initial velocity, plus acceleration times 0.02 seconds. When you simplify that, you get 68 meters per second equals 0.02 seconds acceleration times acceleration. And then when you simplify that, you get acceleration equals 2,900 meters per second, or 2.9 times 10 to the third meters per second squared. And that is your second part of your answer, which is what is the acceleration of the ball post collision.